So in this video, let us learn about nuclear power plants. So normally for this nuclear power plant, let us learn the atomic number. The atomic number in which the number of protons which is present in the nucleus. So similarly, mass number is the total number of nucleons in the nucleus is mass number. Isotopes means so mass number different forms in different and atomic number is same. So in isotope the mass number will be different but the atomic number is same. So then the binding energy, the energy which is released most at the combinations of two nucleons in order to form the nucleus of the atom. So one binding energy equal to 1.602 into 10 to the power of minus 9 joule. So then radioactivity. So radioactivity is nothing but spontaneous emissions of powerful radiations exhibited by the heavy elements such as uranium, plutonium. Okay. So generally nuclear fuels are uranium-233, uranium-235, plutonium-238, plutonium-239, plutonium-241, neptunium-237 and curium-244. So we know generally most often used fuels are uranium-235 and plutonium-239. So in uranium-233 was used in the test bombs in USA and is supposed to be the main components in Indian bombs. So mostly the uranium and plutonium is the major components of fuels, and under this the uranium-233 is used for the test bombs in USA, and also it is the major most component for the Indian bombs. So here uranium-92 to 238. So here the 92 which represents the number of protons in the nucleus and 238 which represents the mass number and 146 represents the number of neutrons, the U which denotes the uranium. So uranium-235. So in uranium-235 the general facts are the isotopes of uranium maximum found in uranium-238 and also in 235, but in 235 only it found in low proportions under percentage of 0.71 percentages. So in fission process generally one slow neutrons strikes a uranium-235 atom, the result is uranium-238. Then the uranium-36 is highly unstable and it is fission. So there are 20 different fission processes. The product's masses always add up to 36. So for example, uranium-235 means fission process equal to plus 1 neutrons which gives 2 neutrons and plus energy. So and plutonium-239. So in plutonium-239 is very nature, and for military purposes the uranium-238 is used in obtaining processing for the breeder reactors. These are the energy equivalents. So 1 ton of coal which having 3 barrels of oils, 40 to 1 ton coal which having each 42 gallons. So generally we know what is meant by nuclear fission. So nuclear fission is nothing but a splitting of nucleus into two nucleus or smaller masses, which is said to be nuclear fission. So one large atom which separates, which splits the nucleus into several nucleus or smaller nucleus plus energy. And nuclear fission, so this one is nuclear fission. When it hits the atom, it splits the nucleuses. The energy is released by fissing fragments. So similarly nuclear fusions. So nuclear fusion is nothing but combining of two nuclei with low masses to form one nucleus of large mass. So fusion is nothing but the two atoms fused together to produce a larger atom with energy. So chain reactions. So chain reaction is an ongoing fission reactions. So here the reactions which occur each chain reaction. So billions of reactions may be made in each second chain reactions. So nuclear power plant. So we all know nuclear power plant. So here the nuclear power plant, the major components are steam generators, control rods, uranium fuel, reactor vessel, containment building and pump. And similarly, the nuclear power plant components having turbine, generator, transformers, cooling waters. So major components of nuclear power plants are fuel rod, reactor, control rod, pump, pressurizer, heat exchanger, steam generator, steam line, turbine, generator, transformer and condenser. So the fuel rod. So we know the working principle of nuclear power plants. So in nuclear reactor, with the help of nuclear fusion chain reactions, the heat is liberated and then it produces the steam. The steam is fed to this turbine which is coupled to the generator. It produces electricity. So generally the fuels are moderated. The process of a nuclear reactor which produces the hot steam, and the hot steam is fed to this turbine which produces mechanical output. With the help of generator it produces electricity. And the same thing, the condensed steam is cooled with the help of cooling tower, and the hot gases also passed through this tower. So major components of nuclear power plant is, first one is fuel. So here the uranium 232 is mostly preferred for high melting point, and it mostly fissionable material used in this reactor is said to be the fuel. The most commonly used fuels are uranium, plutonium and thorium, and moreover for high melting point, apart from this, uranium is mostly preferred for the high melting point. And moderators. So in moderators only neutrons of low speed should be used in order to control the chain reactions. So moderator to slow down the speed of neutrons. In order to slow down the neutrons, the moderators are majorly used, which produces during the fission process. So during fission process, the fast moving neutrons are lead to damage. So in order to slow down the neutrons, fast moving neutrons, the moderators are used. So the moderator which reduces the speed of the neutrons by absorbing its energy but not absorbing by neutrons. So here the most commonly used moderators are heavy water. So for other kinds of moderators are graphite and beryllium are most commonly used moderators. The next main component is control rod. So control rod which absorbs the neutrons and stop the chain reaction to proceed the further. So moderator which control the chain reactions, and moreover it control the speed of the neutrons bombardments. But in control rod it absorbs the neutrons and stop the chain reaction for proceed further. So a controller which is made by steel, so it having the high percentage of material like boron which absorb the tendency to absorb the neutrons. So when control rods is inserted into the moderator block, then all the neutrons are absorbed and reactions comes to halt. Then shielding. So shielding generally used to prevent the radiations to reach outside the reactors. Some of the neutrons are lead over out. So in order to lead the blocks and concrete enclosures that is strong enough of several meters thickness are used for this shielding. And coolant. So here the coolant is nothing but a substance in a pipe to the steam generator where water is boiled. So here the heat exchange process is occur by the coolant. Here the heat is absorbed by the coolant that is produced in the reactor. So from the reactor the coolant gets absorbed by the heat. Several typical coolants are generally water, and others are carbon dioxide gas or liquid sodium. Then turbine components. So another major component turbine. So steam produced from the nuclear reactor, the steam is produced. So the steam produced in the boiler, that is nuclear reactor, which is passed to this turbine. The force of the steam jet causes the turbine to rotate, in which the steam, the heat energy from the steam is converted to the mechanical energy with the help of this moving turbine. So there are several kinds of reactors. So which one is boiling water reactor, pressurized water reactor, Candu deuterium uranium reactor, fast breeder reactor, gas cooled reactor, and liquid metal cooled reactors. So the boiling water reactor which having the boiling water component, and in pressurized water reactor which having the pressure tank in order to maintain the pressure. So these are the various types of reactors. Thank you.